Welcome to Applied Intelligence, where intelligence is applied, not just learned. In this tutorial, we will learn about loop control structures in C programming. Loops allow programs to repeat a set of instructions multiple times efficiently, without writing the same code again and again. We will discuss the three major looping statements in C, such as for loop, while loop, and do-while loop. We'll understand their syntax, flowcharts, and program examples step by step. So what is a loop control structure? A loop control structure is used to create a block of code as long as a condition remains true. Instead of writing the same statement many times, loops automate repetition. Now, dealing with the loop control structure, you have to take note of the following. Number one, you have to initialize a variable. Second is there is a condition, so you have to check the condition. Third is execute the statements under the true condition or under the body of the loop. Fourth is you're going to update the variable, the one that you initialize. It's either incremental or decremental. Then the fifth one is repeat until condition becomes false. Now, what are the types of control structures in C? So let us start with the for loop control structure. For loop syntax. So you have the for, then the condition. So inside the condition are the following. So you have the initialization, initializing the variable to either 0 or 1. Then there is a semicolon. Then next is the condition. Then lastly, update. But before you do the update, you have to go first to the body of the loop. All the statements will be executed prior to the update. For the update, it's either you increment it or decrement it. So this is the syntax for our for loop. Now let's have an example program. So example, let's say you're going to write a C program to print the numbers 1 to 5 on the screen. Now, before we go to the program, let us create first the flowchart for us to visualize the logical solution for this problem. We start with this oval. You can say start or begin, begin and end, start or stop, and stop. Next is you're going now to initialize a variable. No need for input. There's no input because the problem asks us to output 1 to 5 on the screen. So we'll proceed with the initialization. So let's have I is equal to 1. In this case, let's have 1. Now we're going to print 1 to 5. So we have 5 numbers. So therefore, we say I has to be less than or equal to 5. Now, if it is true, we go to this direction. So what will happen? So we output now the I. So after outputting the I, okay, we'll increment that later so we can just proceed with the update. I plus plus, or that is equal to I is equal to I plus 1. Then you are going now to loop. So proceed to this direction and that connection there. Then as long as if this is greater than 5 already, so that becomes false. And that's the end of your flowchart. You can say start. You can also say here stop or begin and end. Now, so let us do the simulation. Let us check. Let us simulate this. So let's start with I is equal to 1. Then proceed. Test. I is 1. Is it less than? Or 1? Is it less than or equal to 5? So that is true. Then true, we go to this direction. Output I. So we are going to output I. The value of I is 1. So, for example, let's have a box here. So we have now output the value of 1. And then, next, increment I now becomes 2. 1 plus 1, so you have 2. Then, look, then go back. We'll go to the decision again. What is the value of I? 2. Is it less than or equal to 5? Yes, that's true. And then go to this. I will print the value of I, which is 2. And then increment I, that is now 3. Then look at that. Loop again. And then you have there, for the third iteration, let's have I is less than or equal to 5. So let's change this I to 3. Is it less than? Yes, it's true. Then output I, the value of I is 3. We'll output there 3. And then increment I now is equal to 4. 3 plus 1, you have 4. Then you go back, and then you test back. Is 4 less than or equal to 5? That is still true. And then what happened next? Output I. Output I, the value of I is 4. Then you output 4. Then next is you update the I now becomes 5. Now, to our last iteration, I, which is 5, is it less than or equal to 5? The answer is true. That is still equal. Then output I, what is the value of I? So that is 5. So let's output 5. And then increment I now is 6. When it loops back, so I now is 6. 6 is less than or equal to 5. The answer is false. That's the end of the flowchart. Let us create the program following our flowchart. Again, our program starts with this preprocessor directive. They include directive stdio.h. Next is the entry point to C programming. So you have there, we can just say begin there. Then let's proceed to the for loop. So let's follow the syntax. For initializing, so we can just actually, it's either you can just proceed with initializing it here. I is equal to 1. Or declaring it here. That's the same thing. If you would like to declare it above, no problem. That will still run. And then, next is condition. So what is the condition? I, is it less than or equal to 5? Then followed by semicolon, and then the update. So there you are, I plus plus. And then, what will be the next statement if it is true? So we only have one there. We're going to, one statement, so we're going to output, printf, the value of your I. So since that is integers, so we can just have %d, then your value of I. That's it. And then, then we put here return 0. That's the end of the program. Now let us proceed to the second control structure, loop control structure, which is a while loop. While loop is used when the number of repetition is uncertain and depends on a condition. The condition is checked first before executing the statements. Here's the syntax for the while loop. So you have there the while, then the condition. So you put the condition inside this parenthesis. Then you begin the statements here. And then close the loop. So that's simple as that. The same example I presented previously. Let us write a C program to print the following numbers 1 to 5 on the screen. So again, we're going to print 1 to 5 on the screen, no input there, so we'll proceed to the initialization of the variable. Let's use I. So again, the same flowchart, the same logic. So I have their start, initialize, then testing or condition. So you have 5 numbers. So therefore, we test whether I is less than or equal to 5. If it is true, output the value of I, then increment I, then loop. And then if this is false, that's the end of the flowchart. Or you can say stop and start and stop. Then let's have the program. Begin. You can just also place there the begin. And then let's initialize the value or the variable I. I is equal to 1. And then let us declare that as integer, semicolon. While condition I is less than or equal to 5, then begin. So output I, you can just simply say here, print F. So we put that, enclose that with the begin and end because I have two statements. Print F and then the I plus plus. Let's finish this. So %d for the format specifier of integer, and then \n, and then I have here I. Semicolon. Semicolon, and then that's the end of the while loop. Return 0, and then that's the end. The third loop control structure is the do-while loop. A do-while loop is similar to the while loop, but the statements execute first before checking the condition. A do-while loop executes at least once, even if the condition is false. Now, what is the syntax for the do-while loop? Syntax, you have there the do, begin, then execute whatever statements inside the loop. Then followed by the end, then the condition, inside the parentheses, then semicolon. Now let us do the example that was presented previously. So we're going to still write a C program to print the following numbers 1 to 5 on the screen using the do while loop. The same logic, let's have the flowchart. Start. Then you can now easily proceed to the initialization. Then the testing. So we have 5 numbers. If it is true, output the I, followed by the update, increment the I, then repeat, loop back, connect there, and then if it is false, that's the end or stop of the flowchart. Now, what is the program equivalent of this flowchart? So let's have, again, this directive, preprocessor directive, stdio.h, then the entry point to C programming, then you have begin. Now let us have this initialize I is equal to 1, and then that is integer data type, then followed by the syntax for do while do, begin. What are the statements inside the loop? So you have there print f, the same manner. So you have the %d \n because I would like to see the 1 to 5 on the screen vertically. Then you have the comma and then the I. Semicolon and then increment I. Semicolon and then end. Then the condition. You write the condition here. I is less than or equal to 5 followed by semicolon. Then that's it. That's the end of the program. And loops are used in many real-world applications, such as ATM systems, login system, game development, repeating menu programs, data processing, and many more. Understanding loop control structures is essential in programming because repetition is one of the core foundations of automation and problem solving. Practice creating your own loop programs to strengthen your logic building skills. If you found this tutorial helpful, make sure to like, subscribe, and follow for more programming tutorials. Again, this is Applied Intelligence, where intelligence is applied, not just learned.